The density of a solid ball is to be determined in an experiment. The diameter of the ball is measured with a screw gauge whose pitch is 0.5 mm and there are 50 divisions on the circular scale. The reading on the main scale is 2.5 mm and that on the circular scale is 20 divisions. If the measured mass of the ball has a relative error of 2%, the relative percentage error in the density is. Okay, so in this question, let's first find out the least count of the measuring device. So least count of the screw gauge is given by pitch divided by number of divisions of circular scale. Number of divisions on circular scale. Now pitch is given by 0.5 millimeter. So this will be 0.5 millimeters and number of divisions on circular scale is 50. So this will be 0.5 divided by 50, or I can write it as 5 by 50 into 10 to the power minus 1 millimeters, or this will be 0.01 millimeters. Okay, so this is the least count and of the screw gauge. This is the least count of the screw gauge. Now we are using this screw gauge to measure the diameter of a solid ball. So there is a solid ball and we are using this screw gauge to measure the diameter. Okay, and it is said that the main scale reading is 2.5 millimeters and circular vernier scale reading is 20 divisions. Okay, now the total reading is given by, if you are using a screw gauge, the total reading is MSR plus BSR into LC. Now MSR is 2.5 millimeters, BSR is 20, vernier scale reading is 20, this is main scale reading. So 20 into least count is 0.01 millimeters, or I can get it as 2.5 millimeters plus 0.2 millimeters. So this will be equal to 2.7 millimeters. Okay, so this is the total reading, or this is the diameter of the solid ball. So diameter of the solid ball is 2.7 millimeter. Now the question is to find the relative percentage error in density. So we know the expression for density. Density is given by mass by volume. Since it is a ball and it is in spherical in shape, I can write rho is equal to m by 4 by 3 pi into r cube. Now using the law of errors, I can write the relative error in density is equal to, since mass is a constant, so mass is not a measurement. Okay. Okay, mass is also a measured quantity, so we have to consider its errors also. So it is given that the measured mass of the ball has a relative error of 2%. So that means delta m by m into 100 is equal to 2%. Okay. Now we have to find the relative percentage error in density. So I can write delta rho by rho is equal to delta m by m. So from this relation we can write delta rho by rho is equal to delta m by m plus 3 into delta r by r. Okay, now I can multiply every term with 100. So the relative error becomes percentage error. Now I can substitute for the value of delta m by m into 100, that is 2%. So this will be 2 plus 3 into, so what is the error in radius or diameter? Okay, so we know that radius is equal to diameter by 2, or error in radius is same as the error in diameter. So instead of writing delta r by r, I can write delta d by d into 100. Okay, so I can write it as 2 plus 3 into, so we are using a screw gauge for this measuring the diameter, and the least count or the error in screw gauge is 0.01 millimeter, and we have measured the diameter as 2.7 millimeters. So this will be 0.01 millimeters divided by 2.7 millimeters into 100. Okay, now we can just cancel this. So this will be 3 into 1 into 10 power minus 2 divided by 27 into 10 power minus 1 into 100 or 10 square. Now we can cancel this, so this will be 3 into 9, and we can cancel this 10 power minus 1, so I can write it as 2 plus 10 by 9. Okay, 10 raised to minus 1 into 10 power 2, this will be 10 by 9. Okay, so if I do it, I will get 2 plus 1.1, so that will be approximately equal to 3.1%. Okay, so that is the percentage error in density. So delta rho by rho into 100 is a percentage error in density, so that will be equal to 3.1%. Okay, so hope you understood this solution. So the option number is option C. Okay, thank you.